Hi there, welcome to another math session, and this time I will be talking about cumulative frequency. Um, this material is uh, designed for DPMAT SL application and approaches in particular, but this material also relevant for other program, I believe. Okay, let's start off with a definition. A cumulative frequency graph or ogive is a graph constructed using the cumulative frequencies of the data. If you remember uh, the frequency distribution table, like this one here we have the frequency, and cumulative frequency graph is used by accumulating all of these frequencies, yeah, and we will see that later on, right? Then why do we use ogive? What is the effectiveness? Well, uh, here we are still talking about uh, presentation of data, and by using ogive, we can see information clearer, such as the median, quartile, percentiles, range, and IQR, yeah, directly from the graph. So that's why we use ogive. We can extract these information easier. Yeah. Okay, so let's jump straight to some examples. Okay, here we are given a raw data, which is about the time taken in second for a student to finish a donut. Okay, and here are the set of data, continuous data that is, and the instruction is, it says the above raw data must be arranged using frequency so that we can easily read and process the data. Okay, so we need to make a table first, a table for continuous data. Yeah, so given that the data is arranged into 6 classes, so we know the number of classes. So all we need to do is to pick the convenience starting value and ending value. Starting value relate to the lowest lowest value, which is 4. So we round this down, and the ending value related to the highest value, which is 30, and it remains 30 because it's already a convenience value, right? So there you go. Okay, so we have maximum value minus minimum value divided by the number of classes, Here we have a maximum value subtracted by the minimum value divided by the number of classes, which is 6, and that gives us 4.3. And remember the rule that we have to round this up into 5, right? Then we can make a table, right? And there are 1, 2, 3, 4, 5, 6 classes, and this is the class width, right? So there you go, like so. All right, and next, it is mentioned earlier that cumulative frequency graph use the accumulated frequency, so we need another column labeled cumulative frequency. So we start off with the first value, which is 2, and then 2 plus 9 gives you 11. 11 plus 9 gives you 20. 20 plus 8 gives you 28, and so on. So this is the cumulative frequency. Next, what we do is we make the cumulative frequency graph or ogive, and we use the upper limits to help us plot points. So in the x-axis is time in second, and in the y-axis is the cumulative frequency. So in the first interval, the upper limit is 5. So you look for 5, right? And the frequency is 2. So 5, 2, and then you give a cross. Yeah. Next, in the next interval, the upper limit is 10, and the cumulative frequency is 11. So you find 10, right, in the x-axis, and then find 11 in the cumulative frequency axis, and then you give a cross. And you do the same thing to the other 4 crosses, right? Next thing to do is that you draw a smooth curve. Yeah, again you draw a smooth curve, and that is your cumulative frequency graph, or ogive. And as mentioned earlier as well, ogive is used so that we can extract informations easier, information such as median, quartiles, percentile, range, and IQR. And this is what we are going to do next. All right. Okay, let's start off with some notes. Since we are going to find quartiles, so let's take a look at the definition. Quartiles are used to summarize a group of numbers. Instead of looking at a big list of numbers, you are looking at just a few numbers that give you a picture of what is going on in the big list. So say you are given this set of data, and by using quartile, you will split the data into 4 equal sized groups. So you start off with the median first. So you divide the data into half, okay, and that is the median. So you have the lower half of data, and you have the upper half of data. Now, at the lower half of data, you divide again equally, right? Then you have the first quarter and second quarter. And if you look at the upper half of the data, you divide it again equally to have the third quarter and fourth quarter. So that's uh, how you find, or how you divide a set of data into quartiles. Yeah, if you can see here, the median, or Q2, is 36. It comes from 32 plus 40 over 2. Yeah, and for the first quartile, or often called lower quartile, it's equal to 26 plus 27 over 2. That gives 26 and a half. Similarly, the third quartile is equal to 50 plus 52 over 2 is equal to 51. So that's some notes on quartiles. Okay, you can read this later on. Okay, then let's extract the information of quartiles from the ogive. First thing first, let's find out where the median is. And median occurs at 50% of the total data. So the total data, as you know before, is given, which is 32. So 50% multiplied by 32 is equal to 16. So in the cumulative frequency axis, you find 16, and then you go across, find the intersection, and then you go down, and then find the corresponding value of time. Okay, that is equal to 12 seconds. Therefore, the median is 12 seconds. As simple as that. right? Next, how do we extract lower quartiles or Q1 from the ogive? Well, we know that lower quartile or Q1 occurs at 25% of the total data, which is at 32 multiplied by 25%, which is equal to 8. So you find 8 from the graph, which is there, and then you go across, yeah, find the intersection, and then you go down. Okay, then find the corresponding value of time, which is 8 seconds. So the lower quartile or Q1 is 8 seconds. Yeah. Next, how do we find Q3 or the upper quartile? Well, it occurs at 75% of the total data, which is at 32 multiplied by 75%, which is equal to 24. Then you find 24, yeah, in the y-axis or in the cumulative frequency axis. You go across, find the intersection, and then you go down. So the upper quartile or Q3 is equal to 17 seconds rather, sorry. Right? All right. Now let's extract information uh, about IQR from the graph. And to find the interquartile range, we need lower quartile, okay, and we need upper quartile. Okay, so Q3 is the upper quartile, Q1 is the lower quartile. So IQR is equal to uh, upper quartile subtracted by the lower quartile, which is 17 minus 8. That's equal to 9. So the interquartile range is 9 seconds, right? So that is the meaning of the IQR, which is the variability or spread out of the middle 50% of the data. In this case is 9 seconds. So 9 seconds is the spread out of the 50% of the data. Yeah. Okay, next, how do we extract information about range from the graph? Well, we know that range is equal to highest value minus the lowest value. Okay, and we know that the highest value is 30 and the lowest value is 4. This is given in the questions. So the range is equal to 30 minus 4. That's equal to 26. And this range gives us a measurement of how spread out the data set is. So the entire set of data, yeah, in this example is 20 seconds. Okay. Now last one, often in the question you're asked to find percentile. Okay, a percentile is a measure used in statistic indicating the value below which a given percentage of observation in a group of observation fall. In this example, let's try to find the 10 percentile. Now 10 percentile means 10% of the maximum value, which is 10% multiplied by 30. Yeah, 30 being the maximum value, and that is equal to 3. So you find 3 in the y-axis or cumulative frequency axis. You go across, find the intersection, and then you go down, right? So 10% of the students, or 3 students, eats a donut in 5 seconds or less than 5 seconds. So that's the 10 percentile. Okay, let's do uh, a couple of more examples. Okay, take a look at this one here. A student measured the diameters of 80 snails' shells. His results are shown in the following graph. The lower quartile is given, which is 14 millimeters. Okay. Okay, let's go to the question. Question A. On the graph, mark clearly in the same way and write down the value of the median and upper quartile. Okay, so we're finding the median. Okay, that's the median. And okay, that's the median, which is half multiplied by 80. Yeah, because we are given 80 snails. So half multiplied by 80 equal to 40. And then you go across, find the intersection, and then you go down. So the median is 20 millimeters. Yeah, don't forget the unit. Okay, next we're finding the upper quartile, which is 3 over 4 multiplied by 80. That is equal to 60, right? And then you go across, find the intersection, and then you go down, and that's equal to 24. So 24 millimeters. For the interquartile range, you need to find the lower quartile, because interquartile range is upper minus lower quartile, or Q3 minus Q1, and this is the lower quartile, or Q1. So interquartile range is equal to Q3 minus Q1, or 24 minus 14. The answer is 10. Okay, although in the exam this answer is also accepted. Yeah. Okay, another example. In part A, it says write down the number of students who scored 40 marks. Okay, so you look at the uh, mark axis, find 40, you go up, find the intersection, and then you go across, right? So there are 100 students score 40 marks or fewer. Okay, and in part B, you're asked to find the middle 50%, so you need to know the upper and lower quartile. The upper quartile is 3 over 4 times 800, give you 600. You go across, find the intersection, and then you go down. Okay, and similarly, that's 75, by the way. And similarly, to find the lower quartile, you do 1 over 4 times 800 is equal to 200, right? So find 200 in the y-axis, you go across, find the intersection, and then you go down, right? So that's 55. So therefore A is equal to 55 and B is equal to 75. Okay, so there you go. I hope you understand the concept of how to make cumulative frequency graph and the effectiveness, right? Okay, thank you very much for watching. Take care.